Okay, I'm here with tonight's video homework. It's the 2017 number 5. It is a DIVA problem, and it is our first non-calculator problem to look at. So just so you know, when we're doing non-calculator problems, they don't really want you to do much computation. They'll most likely ask you to do a little factoring, not too much though, and then there will almost always be a number line. Let me show you what I mean. We're going to be asked a lot about whether functions are increasing or decreasing or going to the left or going to the right. We're going to make number lines to find places where those graphs are equal to 0. And then we're going to look to see if things are positive or negative to tell us whether functions are increasing or decreasing. So let's take a look at the first part of the problem. Okay, they're giving us two particles moving along the x-axis from time 0 to 8. The position of particle P is given by this equation. This is the location of P. X stands for displacement. While the velocity of particle Q, different particle, at a given time is given by this velocity equation for each one. And then they're giving me some information on particle Q. Particle Q is at position 5 at time 0, which probably means we'll be integrating something because they're giving me a starting condition, which I'll add in later on. So let's see what they're asking me here. Okay, they're saying for 0 to 8, when is particle P moving to the left? Well, we know they're asking about particle P. The particle P is moving to the left, this direction, when the velocity is negative. Now they're giving me the equation for displacement. So to find the velocity, I'm going to take the derivative of that function, which I've done right here. Vp equal the derivative L of something is 1 over something times the derivative of V inside. And now I need to know, I've rewritten that equation. I left that part off. Let me get that on there. Plus 10. So when we're going to work on these problems to tell whether it's moving to the left or to the right, we're always going to be looking for places where the velocity is 0. So you look at this equation, nothing on the bottom is going to make it 0. What number on the top could make this 0? And the correct answer is 1. 1 could make it 0. And now I need to know whether the velocity on either side is positive or negative. Now I'm not looking to really find a number. I'm just looking to check the sign, the SIGN of things. So I'm going to pick a number to the left of 1 and put it in and see if I get a positive or a negative number. So I'm going to use the number 0. If I fill in 0 into this slope equation, I get negative 2 over positive 10. So that tells me that before there, the velocity is negative and the graph is moving to the left or down. And now I'm going to double check it afterwards. I'm going to pick a number bigger than 1. So I'm going to pick a really big number. I'm going to pick 100. Okay, and if I put 100 in the top, if I put it in here, I'm going to have a positive number on top. 100 squared is going to be bigger than everything combined. It's going to be positive on the bottom, so it's going to have a positive answer right there. So the answer is, so for the first one there, between time 0, I know everywhere before 1, it's moving to the left. So when is the particle moving left for time 0 to 8? That's between 0 and 1, between those two intervals. Now, should I include 1? No, because it's not moving to the left at that time. It's at a velocity of 0. Okay, second part says for time 0 to 8, find all times when the two particles are traveling in the same direction. So I got to check direction for the next function, for x. I have to check the direction for particle Q. Well, they only gave me the velocity equation for particle Q. Well, good. That's going to let me know what direction it's going in, and that's going to allow me to find the values. But what I'm going to do is I'm always going to find where the velocity is 0. Now, this is about the level of factoring that I ask you to do on a non-calculator problem. So I factored this equation right here, and you'll see it's pretty straightforward. I got t minus 3 and t minus 5. So I know that the velocities at those 2 points were 0. So now I have to test numbers in those intervals to see what the velocities are. So I'll pick a number less than 3. I'll put in 0. So 0 minus 3 is negative. 0 minus 5 is negative. That means in this interval, the velocity is positive. Pick a number between 3 and 5. Let's go with 4. 4 minus 3 is positive. 4 minus 5 is negative. So in this interval, it's negative. And then for the end part, pick a number bigger than 5. Let's go with 6. 6 minus 3 is positive. 6 minus 5 is positive. So it's positive in this interval, so it's going up, down, up. So where is it going the same direction for both sides? Well, it's never going, they're never both negative. I should put those times on there, 0 to 8. So if I look at the first graph, I could see it was positive after 1. On this graph, it's positive between 1 and 3 and 5 and 8. So the times where it's moving in the same direction is between 1 and 3 and 5 and 8. Oop, run out of room. 5 and 8. I didn't write that very well. Let's erase that quick. Comma 3 and 5 and 8. Okay, part C says find the acceleration of particle Q at time t equals 2. Well, they gave me the velocity for that equation. Give me the velocity for Q. So the acceleration is just the derivative of velocity. And I found that equation there. And I filled in 2 for velocity and acceleration. I found the velocity at time 2 is 3. And the acceleration at time 2 is negative 4. Therefore, it wants to know if the speed is increasing, decreasing, or neither at time t equals 2. Well, what is the velocity at time 2? It's 3. And the acceleration is negative. So is this article speeding up or slowing down? It is slowing down because V is positive and A is negative. And the last piece, and that's all you need for an explanation. The last piece says find the position of particle Q the first time it changes direction. Okay, so the position is going to deal with displacement. Okay, we know it changed direction at time t equals 3. We can look back at our chart from before to realize that happened. So its displacement at time t equals 3 is the integral from 0 to 3 of that function, because displacement is the integral of velocity. So I've written this integral out, and now they're actually going to have me integrate this one. So it's going to be 1/3 t to the third minus 8 over 2 t squared plus 15t, oh, that's a t, from 0 to 3. I forgot dt on there. Okay. Now, you don't have to figure these numbers out. You just have to put them in. The zeros go in and do nothing, so I'm going to write this as 1/3 3 to the third minus 8 over 2 3 squared plus 15 times 3. And I could leave that as an answer if that was my right answer. But notice there's a piece of information here. If I look back in the problem I haven't used, is that particle Q is at position 5 at time 0. So what this says is between 0 and 3, this is how far it goes. But it was already 5 units in, so I'd have to include that like that there. Don't worry, if you don't get that part right, like I said, the last part is always bonus in getting all the pieces right. But always realize I'm not going to give you extraneous information. They're going to stuff you're going to use. If you don't like my numbers all written out like that and you want to solve it on out, it usually ends up being pretty straightforward. This is 3 times 3 times 3 over 3. Cancels the cos squared, so it becomes 9. 3 squared is equal to 9 times negative 4 is negative 36. And 15 times 3 is 45. Plus 5. If I wanted to add all those together, I could end up with 23, but it's not necessary to do all those steps. You can leave it right here. Okay, I know I did that one kind of quick, but it gives you the idea of the displacement, velocity, and acceleration. And I will see you tomorrow.